This video will serve as an introduction to the physics behind mirrors. But before you can know some things about that physics of mirrors, you have to know some important terms. For the most part, these terms come in groups of two. First of all is a real image. A real image is an image that can be projected onto a screen. For example, the image that a projector creates is projected onto a screen, and therefore that's a real image. A virtual image is one that cannot be projected onto a screen. You'll see examples of both of these images as we do activities in class. Next up is the object distance, represented by the lowercase letter p in equations. The object distance is the distance from the object to the mirror or to the center of the lens, as we're working with lenses. Likewise, the image distance is the distance from the image created to the mirror or to the center of the lens. This is represented by the lowercase letter q in equations. When there are parallel light rays hitting a mirror, they are all reflected and meet at the focal point. Similarly with lenses, when you have parallel light rays coming toward a lens that refract through the lens, they would meet at the focal point as well. That's represented by a capital letter F, and rather than using that in equations, we'll have that point on diagrams. The focal length is the distance from the focal point to the mirror, or the distance from the focal point to the center of the lens. Finally, the center of curvature applies only to mirrors. Specifically, it applies to spherical mirrors. Spherical mirrors are ones that act as if they are cut out from a sphere. We'll see examples of those in class. The center of curvature would be the center of the sphere that those mirrors were cut out from. Again, that's a point that we'll see on our diagrams rather than in equations, and we'll represent that point by the capital letter C. Now let's learn a little bit about some specific types of mirrors. We'll start off by studying flat mirrors. Flat mirrors are the typical types of mirrors that we use. Think of like your bathroom mirror or kind of a handheld mirror often. Actually, even a rear view mirror is often a flat mirror. The images that are formed in the flat mirrors form at a point where rays of light actually intersect or where they appear to originate from. As you can see in the diagram shown here, here's our point where they originate from. It's like you're looking at some other object in the mirror rather than looking at yourself. And those light rays that reflect off the mirror come to our eyes appear as though they're coming from behind the mirror, the spot that is labeled with an I on this diagram. Now, that's a little bit strange to think about. We've been taught from a very young age that what we're seeing in a flat mirror is simply our reflection. We're not used to thinking of it as an image, but it is. If you've ever seen an animal or maybe even a baby look at a mirror, they usually either bark at the mirror if it's a dog, or sing to the mirror if it's a bird, or cats often will paw at the mirror. Same thing with babies. A lot of times they'll reach out through that mirror. That's because they think that there's something on the other side of the mirror. And that's because the image is on the other side of the mirror. Now we know that's silly. You can't possibly have something on the other side of the mirror. But that's the way that it appears. Because it's on the other side of the mirror, we would consider this to be a virtual image. If I were to put a screen at that place, there wouldn't be anything on my screen, because we know that light does not pass through the mirror. We'll see some examples of this in class. A few other important comments about flat mirrors. You'll notice from the diagram that the object distance is equal to the image distance. This is always the case. Also, the magnification, a term we'll learn more about later, is equal to 1. That means that the object is the same size as the image. Now, You may have wondered why mirrors flip images horizontally but not vertically. In other words, if you're looking at a mirror and you raise your right hand, it looks like you're raising your left hand. But it doesn't flip you upside down. To learn more about why this is the case, check out the link posted on Edline. That's pretty much all we need to know about flat mirrors. Let's look at some other types of mirrors. When mirrors aren't flat, obviously they're curved. The two types of curved mirrors that we will study are concave curved mirrors and convex. They're both spherical mirrors. Again, that just means that they were cut out or punched out from a sphere. And this diagram that you see here, this image that you see here, is an example of a concave and a convex mirror. Obviously, the images look very different. We will learn more about the properties of concave and convex mirrors in a future class. However, it's important to know what these two mirrors look like. Concave mirrors are like you're looking into the side of a spoon that you would eat with. Now, spoons are not spherical in nature, but you probably kind of get the idea. In other words, if you have a concave mirror and you were looking into it, it would look something like this, where you're looking into it from this side. A convex mirror would be like the back of a spoon. So if you were looking into a convex mirror, it would be like you're looking at that side of it. The properties of concave and convex mirrors are a bit different and are something that you'll discover through some activities in class. That's it for now about mirrors. Stay tuned for more information.